So today's lesson, I'm going to tie in everything that we've been doing with the rule. So there's four pieces to this puzzle. We have the rule, which we've been learning about. We have the table of values, which looks like this. This was our table of values, or like this, our table of values. We had the rule that looks something like this, plus 5 equals y. This was a rule that we've just learned from the table of values. We have graphs. We're going to be able to graph the table of values. So the graph usually looks like this, a straight line. We're going to do that. And today we're introducing the word problem, the word problems that lead us to these three other parts. So I can give you the rule, and from the rule, you would be able to find a table of values. From the table of values, you'd be able to find the graph, and you would kind of know what the word problem is with it. Or I can give you the word problem, and then you can graph the word problem, find the rule, and these all can be interchanged to be able to be together. Okay, so they all are saying something in a different way. So how are we going to start this lesson? By putting the title. And these are the three examples from our book that we're going to use to learn this lesson. Okay, so we're going to start our lesson on graphs and functions. And we're going to use three numbers from our red book, number 8, number 10, and number 7, as examples to guide this lesson. We're going to start page 65, number 8. So I asked you all to write the question. There's the question. Nancy, the physiotherapist, she earns $225 plus $25 per patient she treats during the week. This question is always on tests, final exams, and midterms. This type of question is always there. So everything we've learned in the last couple of days, the last couple of lessons, was about the rule. How to find the rule. But we were finding the rule from the table of values. Agreed? So our homework was find the rule, and it was all based on the table of values. How to find the rule from the table of values. But now I want you to find the rule from a word problem. What does this mean? Well, let's say Nancy has no patients that week. She doesn't see anybody. How much would her salary be? How much would her boss give her if she sat in her chair and read a book for a week but saw no patients? Yes. $225. $225. Can we all agree that $225 in my rule would be the initial value? It would be something that never changes. Could you agree with that? And how about this $25? Who thinks they know where this $25 would land in my rule? So right now I have plus 225. I hope you all see that this was the initial value we were doing. Initial value. Nothing changes. I'm still getting 225. And who thinks that they know where to put the 25? Yeah?
25x.
25x. That's amazing. 25x. Now I know my marker is a little light. 25x plus 225 equals y. I have now found the rule from this word problem. This is the initial value. This changes depending on if I have 1 patient, 2 patients, 3 patients. Let me give you another example of how to use the rule in a situation. where there's an initial value. So let's say a taxi, you walk into a taxi and it costs $3 before you even move. $3 before you move, before you drive anywhere. The $3 would be the initial value. So you would have the plus 3. And then I said it costs you 50 cents per kilometer. Well, then I would have to write 0.50x plus my $3 would give me the cost of what they would charge me. So depending on how far I'm going, plus the $3, which was an initial value, would equal to how much I would have to pay. Now, are there places, so let's say I talk about Costco, and I have to buy a membership to go to Costco. There's an initial value. If I play tennis, boom, I'm playing tennis, I need to rent the court. So it costs me $15 to rent the court, and it costs me $5 for every game that I play. Well, then it would be 5x plus the $15 rental equals how much they would charge me for the hour. And this relationship here is what we're doing. This is what we were learning the rule for. Now, there's times where you have no initial value. For example, if I walk into Maxi and buy an apple, if I buy one apple, it costs me $2. If I buy 2 apples, how much is it going to cost me? $4. If I buy 3 apples, $6. Did it cost me extra to walk into Maxi? No. So it's a proportional situation. Means that if I buy none, how much do I pay? 0. And on a graph, that would look like this, right? At 0, 0. I buy nothing, I get nothing. On a table of values, it would look like this. At 0, what's happening? 0. Okay, so that would be more of a proportional situation. And then there's others that have an initial value of more than 0 where you have to pay. Or what we're talking about, whatever we're talking about. So let's go back to this rule that we've all created together from this word problem. Now what I want you to do is take this rule and make a table of values. So the table of values will look like this. X and Y. Now, can we choose 4 numbers that we agree on? I would suggest 0, 1, 2, and 3. So 0, what would be my Y? 1, what would be my Y? So 0, 25 times 0 plus 225 equals how much? 225. So therefore, if I get no patients, I make $225. If I have 1 patient, so I do 25 times 1 plus 225 equals 250. So this is where I would put my 250. If I get 2 patients, if Nancy gets 2 patients, $275. And let's do one more of 3 patients. $300. 3 patients, I make $300. And this is where I'm going to tell you, the independent variable versus the dependent variable. The x, who can tell me what the x is in this situation? What are these numbers 0, 1, 2? What are they? What are they representing? The patients. So my x here are the patients. And who can tell me what the y represents? The y. The payment, the cost. cost, the money. So this guy here is y. Now, which one is independent and which one is dependent? Well, the y will always depend on the x. So the y is dependent on the x, which happens to be independent. So depending on how many patients I have, that's how much money I will make. So these ones are independent, where these ones are dependent on the x. Once I have my table of values, I'm able to graph. So it's the last piece of the puzzle. We have 4 pieces. 1 piece, 2 pieces, 3 pieces, and the last piece will be the graph. So let me go here and place the graph. Now, remember, this is my x. So what are the x's? What did we say over there on the table of values that the graph was, that the x was? The patients. Please label your x as patients.
Are we writing it that in our copy?
Yes. This is a great example to have in your notebooks when you are studying. You will have 1 of each. Okay, so there's 3 examples. This is the typical example where we have an initial value. Patients. So I have 0 patients. I have 1 patient, 2 patients, 3 patients, and so on and so forth. On the y-axis, right here on the y-axis, we will have this. What will we label this? Money. Yes? The amount of money that she earns, Nancy. Now, we are looking at 0 being $225. So I suggest that we start at $225. We start at $225. And then go up, so you're going to do like a little break. And then we'll go up by, look, in this case, I would go up by 25s. So I would go 225, I would go 250, I would do 275, 300 in this situation. Could you go up by 10s? Yes. Could you go up by 20s? Yes. As long as you're consistent on your intervals. Yes.
Miss, what's that squiggly line?
It's just to say that I'm not going to write a number from 0 to 225. I'm going to start at 225 and then I'll go up consistently by 25s. Because or else our graph would be off the chart, off the wall,
Miss,
off the board.
Can you do a bar graph?
It's not a bar graph ever. It is a broken line graph where we connect the dots. So at 0, it's 225. At 1, it's 250. At 2, it's 275. At 3, it's 300. Now, it doesn't look perfect, but it should be a perfect straight line. This is the line I am looking for. This graph could be given to you, and you would have to find the rule from this graph. So if I had no Nancy is a physio, how about if I had no rule and I had no table of values? Would I be able to find a rule from here?
Yes.
Let's just look here. Boom, 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 boom. Can I find the rule? Well, first I would look at the 0 and say, oh, whatever it is, it starts at 225. My initial value is at 225. So I'd be like, okay, there's my 225. And then I would say, oh, from one patient to the next, I went from 25. Oh, I'm going $25. Oh, the next one's another 20. Oh, another 25. Oh, so the 25 is coming from this. So I'd go 25x plus my initial value, which was found at the 0, gives me my rule. So there's a connection with 4 different parts. We have a graph, we have a rule, we have a word problem, and we have a table of values. They're all saying the same thing. Any questions about this? Okay, so we're going to go to number 10 on page, next page on page 66. And we're going to write that question down. So write, a bathtub contains 180 liters of water. Please write that down. So let's do this example. A bathtub contains 100 liters of water. It empties at a rate of 20 liters per minute. Whenever you get a word problem, the first thing I want you to do, if you can, is find the rule. I want you, number 1, to find the rule. Now, if you look at those questions, they ask you for the rule on the last question. It's at the bottom, letter F. If the letter X, which calculative, and they're asking you, write the rule. I don't want you to find the rule at the end because the rule is going to help me answer question A, B, C, and D, and E. So first, number 1 is to find the rule. And what you need to do is say to yourself, hey, is there an initial value? Is there something that it starts off with? And in this case, it starts with 180. This is your initial value. The initial value will be 180, so plus 180. And is it going to change? Is there any change? Is there something that's going to be affected each time? Yes. This is what's going to change. So this here is where you're going to have your X because it depends on how many liters, how many minutes are going down. If it goes down, every minute it's going down, so 1 minute is going to change it, 2 minutes is going to affect it, 3 minutes is going to affect it. So 20X plus 180 equals your Y. Now just with this, my table of values will have a 0, which is my initial value of 180. Do we all agree? Just by looking at this, I could tell this. With my graph, I know it's going to start at 180 and do something like this. This is very general, but I'm showing you where the initial value is on the table of values, on my graph, and my initial value in my rule is this. Initial value, initial value, initial value. Yes? Yes.
Doesn't 20 have to be negative?
Yes. Oh my God. And that's the whole reason why we're doing this question. It's a negative 20 because it's going down. It's emptying. Thank goodness, or my whole lesson would have been ruined. Thank goodness we have students are paying attention. It's negative 20 because it's going down. The water is going down. So this graph is wrong. This graph is wrong. Why? Because I have to take this graph off, start at 180, and guess what's going to happen? It's going to go down. So the graph is actually going to look like this. So the whole reason we're doing number 10 was to show you what happens when something's going down or emptying. So thank you. Are we okay with this? So let's continue by plugging in 0, 1, 2, 3 and seeing what happens at 0 minutes, 1 minute, 2 minutes, 3 minutes, etc. So at 1 minute, we should have 160. At 2 minutes, we're at 140. At 3 minutes, we're at 120. How did I get that? If I plug in 0 here, I get an answer of 180. if I put after 1 minute, I get 160, so negative 120 plus 180. If I do this after 2 minutes, what happens? I get 140, and so on and so forth. On my graph, can I label the x-axis? The x-axis. Can I label this as what? What will that be? What are these numbers representing?
Minutes.
Minutes. So time, which are specifically minutes. So I do want you to write minutes. And what will my y be?
Water loss.
Water, the water, liters. It's how much water I have. So the liters of water. Okay, we know that through the graph that it's decreasing, but what are these numbers representing? The liters of water. So at this point we have 180, and then at 1 minute we have 160, and then at 2 minutes we have 140, and so on and so forth. Now, in these questions that you have in your book, there's questions A, B, C, D, E that we have to answer. And once you've done this, we'll answer them. Okay, is there any questions so far though?
Miss, we made the table of value.
Pardon?
We made the table of value. One of the questions.
Right, so one of the questions says make a table of value. We've also answered determine the independent and dependent variable. So independent is always X. So if we're able to label this and this, then we've answered independent and dependent. So we've answered question A. We have answered the table of values. And now we should answer letters C and D. So once you guys are finished writing all this down, and if you have no more questions, we will answer C and D. I'm going to erase this and answer C and D here. So the rule was negative 20x plus 180 equals y. Question C, right? What is the question for C?
How many liters are left in the flood after 5 minutes?
After, so they're asking for how many liters? This, they're asking for this. After, not 1 minute,
5.
not 2 minutes, 5 minutes. So I have to do negative 20 times 5 plus 180 will give me the amount of liters. So I'm going to do algebra. Negative 100 plus 180 equals 80 liters. 80 liters left. So I've now answered using my rule. The question was after 5 minutes. Could have I found it here?
Yes.
Yeah, I could have continued my graph down, my table of values down to 4, then 5. I'll still get the 80. Could have I found it here? Yes. I find it using my rule. Now watch the next question, because the next question is probably the hardest of all of them. Because now, watch, so letter D is asking a question where they give you which part? They give you Y. They give you the liters. So how many liters here did they ask you for? At 20 liters. So now they want to know how many minutes will it take to have 20 liters left? And what is this, what we're doing here? Bring you back to about 2 weeks ago. What is this called? What is this called? Solving equations. Do we know how to solve so that x is left by itself? Well, we should. We should. We've done enough tests, quizzes, assignments, and homework. we have to bring this over, minus 180, which is equal to minus 160, divided by negative 20.
Yeah.
Final answer,
Possibly.
8. What's this 8? 8?
8 minutes.
8 minutes. 8 minutes to get to the 20 liters. One more minute, and guess what happens? There's no water left. Yes, we've emptied it. All right, yes. So wait, just give me a second to explain. So here it is, number 7, Matt legally downloads music at a cost of $1.50 per song. This question is proportional, and I'll explain what proportional is in a minute. But knowing what you know, and I know Matt, since your name is here, you want to answer the question, what would the rule for this be?
Well, it would be 150x equals y.
Exactly. 150x equals y. This is the rule for this situation. There is no initial value. He doesn't have to pay unless he buys a song. And it depends on how many songs he buys, how much he will pay. So in that sentence that I just said, I said depends, dependent, independent, get it? Depends. This depends on this. This is independent. This is dependent. There is no initial value. I didn't have to pay to be part of a music club. I just have to pay depending on how many songs, or Matt has to pay legally. And we're not talking with taxes or anything at this point, okay? So we're just talking $1.50 for every song. So this situation, I'll show you what it looks like on this graph, which I did earlier. X, Y, 0 songs costs me $0.
Miss, you need to write the 0.
I'm going to show you on a graph what a proportional situation looks like. At 0, it's 0. 0, 0. 0, 0, the origin. It'll look like this. And in this here, you'll notice there's no extra number. So it's only one number that they're talking about. So this is what a proportional situation looks like. This is what a proportional situation looks like. This is what a proportional situation. This is what a proportional situation. What does proportional mean? It means that I'm going up proportionally. I am going up by the same amount each time. And at 0, it's 0. Got it? So now let's fill this in using the rule. So how much at 0? 0. How much at 1? $1.50. So at 1, it's $1.50. At 2, so 2 songs cost me $3. How much does 3 songs cost me? $4.50. And so on and so forth. I can pretty much answer any questions from all of this information that you now know. Please remember to label the X and the Y. This is always independent. This is always dependent. The X in this case, the independent, is how many songs. The dependent, the Y, is money, the cost of my songs. And they ask you a couple of questions. So we've answered question A, the independent and the dependent. So we've answered question A saying that the independent are the songs and the dependent is the cost of the songs. We've answered question B, which asks us to create a table of values. This is all on page 64. Okay, so number 7 is page 64. Then they ask you 2 questions, and that's questions C and D. What do they ask you? Can somebody read me what C says? Question C, what does it say? Really loud, go ahead.
What is the total cost of buying 30 songs?
So I know, what information did they give us? The number of songs, so they said 30, and they're asking us for the cost, the Y. How much is that, $45?
Yeah.
Cost me $45. 150 times 30 equals $45. Question D, a little more difficult. Why? Because now they're probably going to ask how many CDs or how many songs can I get for $22.50. So how many of these? This is an algebra question, solving for equations. Does anybody know how to get rid of the $1.50? Yes? Divide by $1.50. And X now is the number of songs that this will equal to. $22.50 divided by $1.50 is 15 songs. So Matt can buy 15 songs for $22.50. These are 3 examples. So today's lesson had 3 examples of functions, the rule, the word problems, the graphs that are all tied together. And there's a lot of examples in our workbook that we're going to do for the next few days. But these are the 3 different ones. So they have to land in one of these questions. It's either going to, and the most popular, people, is this one here, number 8, where you have an initial value. And then the second most popular is this one here where they're testing to see if you understand proportionality. And then what we see once in a while is this question that decreases. It's not very popular, but it is around. So in the next 15 examples that we're going to have doing this, you should be a pro. Any questions? No? So today's lesson's over. And